Welcome to the eighth episode of my podcast, Feminist Voices. This is your host, Trisha Singh. Feminist Voices is a podcast that empowers women in STEM. Join me to celebrate and amplify the voices of brilliant women making waves in science, technology, engineering, and mathematics. Let's break the barriers, shatter the stereotypes, and dive into their journeys, challenges, and triumphs, and inspire the next generation of women in STEM together. Today, we are thrilled to introduce Ms. Soumya Krishnamurthy, a virtuoso in electrical and electronic engineering. With a BE and a master's in economics from BITS Pilani and a PhD from the University of Maryland, College Park, Ms. Soumya has spent 2 decades innovating in the Silicon Valley, currently leading currently leading cutting edge advancements at Empower Semiconductor in the vibrant city of Seoul in South Korea. Ms. Soumya exemplifies technical brilliance and creativity. Beyond semiconductors and circuits, she embraces the great outdoors such as running, hiking, and tennis, and enjoys Western classical singing, and is passionately involved in inspiring the next generation of STEM enthusiasts. Join us as we dive into Miss Soumya's remarkable journey and explore how she seamlessly blends technical mastery with a dedication to education and empowerment.
Thank you, Trisha. That was a very generous introduction. Thank you for having me on your podcast.
My pleasure, ma'am. So, without further ado, let's dive into the questions. Ma'am, can you please share your journey into the field of electrical and electronic engineering? What sparked your initial interest in this field?
I think as a student back in middle and high school, I was just naturally drawn towards mathematics, towards the physical sciences. Um, but in parallel, also enjoyed I enjoyed history, I enjoyed economics. Um, Economics, as you know, does also include a lot of mathematics. And when I started my college journey, I actually my undergrad was sort of a dual degree. I went to BITS Pilani, which offers you dual degrees. So I decided to study both, kind of explore both. I think of the undergraduate years also as years of exploration towards then deciding, what do I finally want to specialize in. And it is a longer journey in the sense it takes 5 years, but it was eye-opening for me. And I realized what I truly want to do is stay with the engineering side of things. I like building, I like architecting. So I said, okay, this is what I would like to do. So then I pursued my PhD in electrical engineering. I think a PhD journey is an exploration of a different kind. It is a lot of detailed. I guess it's very detailed in what you do, both from coursework and research. But you have those 5 6 years that it typically takes to do your PhD for you to explore in the early years what you want to do.
Right.
Mm, I think the PhD, more than actually solving your problem in the thesis, is the art of finding the problem you want to solve. That's where the learning journey is. And that teaches you a lot that you then take with you through your career. And so after that, I chose to work primarily in startups in the Silicon Valley, which gave me that freedom to essentially look back at the problem, architect, but also build. Build towards eventually making a product that is sort of a product to market. So I think for me it was a journey of exploration throughout, continues to be. I think that's one thing I've learned. It is, you are consistently and constantly learning, which is what makes it interesting for me. So that in some ways is my journey.
Wow, ma'am, I'm very happy to hear this answer. And I think, yeah, especially when you are in this field, there is constant learning and you constantly need to be updated to stay relevant in this field. I think one of
That
my
is great.
questions is
Mm-hmm.
related to that, which I'm going to be asking you soon. Ma'am,
Okay.
so yeah, ma'am, so with 2 decades in Silicon Valley, can you tell us about some of the most exciting projects you've worked on?
So for me, the very first project I was put on was exciting because the extent of what I learned and actually having really good mentors. I was fortunate to start very early in the cycle. And I mean, today it's archaic, but this was when we were developing 3G cellular technologies. And we had to sit back, think through the architecture, the mathematics behind that is somewhat established. But how do I make a product that's distinguished from others? How do I build this? What is the system architecture? How does I'm an analog designer, a mixed signal designer, but I need to understand how is the digital design done? How is the analog design done? How is all of this coming together? How do we design for it to be eventually tested? And then they put me through the entire cycle of the product coming back into the lab, me actually testing, what we built. And it was a 3-year cycle, but the amount that I learned in those 3 years has taken me, has really given me a lot through my career. So from a pure problem statement, it may not have been the most interesting, but I think in terms of what it taught me, how to go about building something, I think was very interesting. Um, I would say my current work with Empower is something that I find very exciting. I've been with the company for 6 years, but the company itself has been here for 10 years, and we still call ourselves a 50% startup. So we're trying to build um, or think through a new way of powering circuits. I mean, anything that sits inside your laptop to your car to your phone has power management circuits. It has to translate what comes in from your switchboard to something that your circuits inside can use. How do you make that more efficient? How do you make it area efficient? How do you make it power efficient? And small incremental changes are not enough anymore, given the complexity of what is getting built. We had to sit back and think of something that is a slightly, I would say, a bigger incremental change, enough that it has a meaning to multiple sectors. It can apply across multiple sectors, not just, it's not just a solution chasing one problem. So I think for me, this current project is very interesting, or it has taken many years of evolution and revisions to get here. But I think I truly enjoyed this. Yeah. So my current project of power management towards what we are building is towards AI servers now, is a very challenging and interesting one.
I mean, it sounds really interesting. I'm pretty sure it
Okay.
would be interesting. Ma'am, what do you mean by analog and digital
Digital. Okay.
design? I think, yeah, you said that.
So when you see integrated circuits sitting inside I mean, you'll see these little boards, green chip boards, and then you have these black little chips. Inside them sit extensive circuits. Some of them are digital in the sense they purely operate on two states, 0, 1.
Yeah,
Analog
correct.
circuits actually generate the zeros and ones, but there are a smaller proportion, but a significant portion of all of that, depending on what you're doing, whether it's memory or power or maybe it's something else, which is designed not to just operate on those two states. It has an analog meaning from 0 to 1. So that's broadly why that's analog and digital. So I primarily do the latter. I would say much smaller percentage of circuit designers do the latter, maybe 10%. But we have to work very heavily. Anybody who's analog is also pretty much mixed signal. We also heavily work with the digital folks and integrate all of this. My job today is very much top level integration because I've worked through the low level design work. Yeah.
Got it.
And does that
I'm
help?
also,
I'm hoping
yeah.
to keeping it simple, but let me know if
No, no, no,
it's a lot
I
of jargon that
understood.
I'm throwing in there. Yeah. Okay.
No, I
Yeah.
understood the terms. And ma'am, by
Mm.
board, do you mean like an Arduino board? Because like I did
Like your
robotics. Yeah.
Yeah, all those are boards. I mean, those are all, you see printed circuit boards, they're green in color, they hack into all sorts of things. You open your computer tomorrow at the back, you open your phone, you're going to find them. Essentially, you have a number of these chips, right, which are integrated onto a board and talk to each other.
Okay.
Some have memory, some are processors, some are, they're transmitting and receiving information, they're modulators. So, yeah, they're all working together.
Wow, this actually sounds interesting. I think after this podcast,
Mm-hmm.
I'm going to research on circuits and, all of
Mm-hmm.
this. Yes.
Okay.
Ma'am, so balancing a demanding career with personal interest can be very challenging. So, how do you
Mm-hmm.
manage to integrate your love for outdoors, music, and traveling into your busy schedule?
I've learned over time that balance is something you might seek on a day to day basis, but really you may not have it on a day to day basis. It's something a long term average you can hope for. So you will have phases where you are incredibly busy with work and therefore cannot travel for pleasure or pursue your hobbies. But I think it's good to build a little bit of time in your week or day to be able to do it. It might just be going out for a walk. Now, I'm very fortunate to live in a city where the outdoors is easily accessible.
Hmm.
Seoul is a very hilly city. The where I live, the river is right next to us.
Wow.
And prior to this, the Bay Area again has a lot of outdoors easily accessible. So all you need is an hour or two of your time, if you can, over the weekend, or if you can in a day, to just go out and do what you want. And maybe it is music, and you play an instrument, practice it. I think taking that break for yourself is I think a good thing. Um, Planning a long thing, which takes several days to go, yeah, that is harder to do, especially when you have a family and all of that to coordinate, but you can prioritize. When your children are young, all of that is a challenging, and you may not be able to do any of it, and I think that's fine, that's okay. But you will get back to it at some point. Yeah, you'll be able to do it again.
Right.
So
I
think of
think
it in small
yeah.
chunks. Don't think of it as this big thing that I have to achieve, and you'll be able to do it.
Right. I think basically time management is key, and you need to know what to prioritize and dedicate specific chunks of time to whatever you want to do. And I think
I
then
think,
you'll
yeah,
be,
that's true for anyone who
yeah,
is
any
trying to balance a
age.
career with any career and your work and your own personal time. It's about balancing and choosing what to prioritize when. It depends
Right.
on the individual and their circumstance. Yeah.
Correct. I think this is even for us high school students. Time management
Yes,
is key. Right.
that
Wait,
is correct.
ma'am,
Yes.
were you good at time management even when you were in high school, or you have learned it when you entered your professional field?
I think I've always been someone that needs to do a little something outside work to be happy. So I think it did, though our high school life for us was perhaps a little less complicated. I think we had exams and tests, and then we had our life. I think for you in this generation, it is a little different. I think the need to manage time, because you do all seem to do a lot more than we did at that age. I think the need to do it is more, and so
Hmm.
you learn those skills earlier. What I learned to do in college, you perhaps in college we had to do that. You perhaps are learning in your high school years. So I think it is something that is key. It's useful all along in your life. Yeah,
Right.
yeah,
One skill I think everybody should have, right?
yes, that's right. Yeah.
Ma'am, so what innovative advancements are you currently spearheading at Empower Semiconductors, and how do you see these developments impacting the industry?
Spearheading is a strong word. As I said, we are a small team and we work together. What we are trying to do is, like I said, the small incremental changes were not enough. What we do powers right now powers servers, and we are targeting AI servers. Power consumption required by some of these servers is now doubling in a couple of months as opposed to 18 months, 2 years. They're very power hungry. What delivers power to them needs to be efficient. And what we have recently unveiled, our system, is something called vertical power delivery. So what we do is, if this is your computational chip, right? If this is what is doing all your computations, we sit right on top of them or right underneath, and and try to just vertically deliver that power. It may sound like common sense, but all these years, what things would, things used to set horizontally would travel to this
Oh,
portion. And there's a lot of magnetics around a power management circuit, which is extremely area hungry. We have developed a way to encapsulate all of that into our package. And that's why I say it's a lot of teamwork. It's not just the chip design, it's also what happens outside of it. How do we deal with the magnetics? How do we package this thing? How does it sit with what we are trying to power? So I think I think we have proof of concept of this working, and I think that's very exciting. And we can actually now think about trying to take it to product, making it a product. So how this changes things is it completely changes the way we think about a power management circuit. It's not this one integrated circuit sitting somewhere far away that's delivering power. It needs to actually coexist with what it's trying to deliver power to. And we have to build the whole ecosystem and understand that ecosystem, model it well. um, I think we've shown that it helps with power efficiency in many cases. So that's exciting. That's exciting. It's not just a little step ahead. We've taken a bigger step at this point. Yeah.
ma'am, I
So
think you mentioned
mm.
about AI powered circuits, right? If I'm not wrong.
Okay. So what we do is we don't do any AI. We power the circuits that do the AI computations. AI computations are very power hungry. They're very, very power hungry. And if you're trying to deliver power to them, you've heard of server farms and
Yeah,
how power
okay.
hungry
Yeah.
they are and how much electricity they take up and how much you have to cool them. What we do is we sit inside, or
Hmm.
we hope to sit right above these little computation chips and make them a little less power hungry
Got
because
it.
we deliver power more efficiently to them. So that's our job. So it's
Wow.
one piece of the puzzle, one small piece of
Yeah,
the puzzle. Yeah,
got it.
yeah,
One small piece of the puzzle that still seems like such a big problem. But yeah.
yeah, yeah, yeah.
Ma'am, so what are your thoughts on the future of STEM careers, particularly for women? And what advice would you give to the young women aspiring to enter these fields?
I think it's very bright. I think of any work in the field of science and technology or mathematics is something that constantly evolves.
Right.
Sometimes you're working to solve specific problems, but sometimes you're thinking more broadly and it fits into solving different problems. And that's the exciting thing. You can choose where you want to be. And if you're interested, I believe in mathematics, if you enjoy it, if you enjoy the physical sciences, if you enjoy, other things, biology, I'll also put economics into this category because it requires understanding of mathematics and, um, I think go for it. I think gender has nothing to do with the line of career. If you enjoy something, know that the doors are open for you. Assume by default the door is open for you, and put one step in front of another and keep going. You're not going to have all the answers. You're not going to know exactly how anything is going to play out, and that's okay. Uncertainty is part of the game. But if you have interest in it, just know that the door is open, and I would say keep going. um, don't in your mind imagine that there is gender associated with any sort of career option, especially this one. I think there isn't, in my opinion, although statistics say otherwise. So
Exactly. Because normally, I mean, this is one question I asked almost
mm-hmm,
all my guests, and
mm-hmm.
they also say that, there are some challenges which women face which men don't experience. And yeah, as you said,
Okay.
statistics also, yeah,
Okay, so
says
I
that.
think that a lot of women given start giving up even before they start trying. I think that's a big part of the
Agreed.
problem. Let's leave that aside. So, are there challenges women face? I think around our families, perhaps. I mean, women have children, right? I would say that's the only difference. But that is for a short period of time. And if you learn to, and there is a lot of support, and now there is awareness now, more awareness now than when I had my kids many years ago. And I
Right.
would say that Even then, I did not have all the answers, but you try to figure it out, get help around it, um, organize things around uh, how, organize that help around what you need. If you're in this field, let me tell you, you'll be able to afford that help. So you've already crossed that barrier. Affordability is a challenge, right? For childcare support, but that's not a challenge you will face if you're in these fields, because you will get well-paying jobs. Yes, I think the families we come from, what kind of backing we have, all of that matters. And I think I do come from a family where I have had a lot of support. And, all of my siblings as well. I have sisters, two older sisters also. I have careers. My mother worked, right? So I had a figure in front of me who I knew had already managed some of these challenges in a previous generation, but in a slightly different way. For me, I had to take the next step forward. I
Right.
understand not everybody has that. I understand
Mhm.
that. So I think this is where trying to see other women do it helps. That there is a
Right.
way. What that way is, we have to each for ourselves figure out a little bit, but maybe learn from people around us. I would say the challenges are primarily around the early years when your children are young, trying to maintain balance,
Mm.
and it's going to be tricky. It is challenging, messy, all of those things. So go with the assumption that's what it's going to be, that it's not like a cakewalk, but it's doable. If this is something you enjoy, go for it.
Yeah, I think at the end, all these challenges and struggles, it's worth it if you really love
Yes,
what you're doing. And
yes,
ma'am, also
yes.
when you talk about health, I think this is where mentors play an important role, right? Mentors, role models, because you look up to them, you learn from them, and then you just figure it out, right?
That's right. I think in your own field, you may take time to find the right mentor, and you may not even. For me, I have never had a mentor of my gender. My mentors have always been men and have been supportive. The percentage of women I've worked with is very small, and
Oh,
we all support each other. And it's not just that you seek support from the women; the men support you too. So go, So I think yes, you see role models, but you have to adapt that role model to your situation.
yeah,
Okay.
right,
So
right,
don't the
right.
role model could be a woman, that's great, because then there will be more things that correlate directly to your situation, or
Correct.
there may be men. And men also have families and they also have spouses who work. So you can also learn from them. Um, but I do believe that at the younger ages, when girls see other women doing it, there's something that
Yeah,
sparks in their head saying, oh, it's possible.
right.
And
Agreed.
I think that is helpful in the early years when you haven't yet, set your way. Yeah.
I think I completely agree with everything you said.
Yeah.
Yes, ma'am. Ma'am, so you're actively involved in high school initiatives to inspire students towards STEM careers. What motivated you to take this role, and what impact have you seen so far?
Um, once actually, I mean, when you're at work and you're interviewing candidates, you see the candidates coming through and you see the proportion of women coming through. It's very small. They exist, but it's very
Right,
small. It's
right.
probably in my field 10%, maybe a little
Oh,
bit more. Probably at 10 to 20%, but by the time my peers are maybe 8 to 10% of the workforce. And in any given meeting, if there are 10 women, 10 people, probability that I'm the only woman in there is very high. And it's something I started noticing early. Um, I noticed that even in grad school, if in my field, if you have some core classes, big core classes, maybe if you have 40 people, you may have three women. That's a good number. But if it's a smaller core class, you probably would be the only one. And I don't know why, but these numbers haven't changed. And as a grad student, I was also a teaching assistant sometimes to the undergrads, and I felt a lot of the really bright girls would say that, I'm switching out of engineering and I'm going to do something else because this is a career field I see mostly for men. And I used to wonder why. And then you trace this back and you start seeing at high school, it's already kicking in, especially 11th and 12th grade. When you're giving, your exams and you're, putting in the applications, you start seeing the numbers dwindling. In elementary school, you never see girls lacking confidence in basic mathematics or anything. You don't see it. This difference from my personal barista of children I've seen, I feel starts in middle school. And there must be some psychologist somewhere trying to research it. I don't know the entire reasons why, but I think intervention has to begin early. The funnel has to be wide
Right.
enough to begin. It will narrow, but at least you need to start hitting the problem early. Now, most of the things I've done in high school are essentially, you know, talks about my own career. What do I do? Try to break it down in a simple way to high school children. And what does it mean practically? Because by that time, by the time you're a junior or senior in high school, 11th or 12th standard, 12th grade, you are, all, you understand. Middle school, you have to break it down even more and try to excite them about it. Try to, tell them
Mm.
what is interesting about it. And at that age, it definitely helps that the woman showed up. Someone who is a woman is standing there and telling me that, hey, this is possible and this can be done. It can be anything. It can be biology. It can be, any of the fields in STEM. Um, so I think I've done more in the sort of high school years, but I've talked to the schools that we should get people in a little earlier to talk to the children, so they see who's out there, what they're doing. Um, and in my own personal circle, I think I do talk to children who are in this, who are interested or might be considering this field. Um, I think that's broadly what I do. I mean, of course, there are IEEE, circles for women and things like that, which career circles for women, but that's at a later stage, which I do involve myself in. And, what we do is it's like a support system in the Bay Area or in the Valley. So we mentor younger engineers coming in and so forth. But everything I do, I offer to both boys and girls. I don't think it should be only for one gender. I think for everybody, anyone interested. But the hope is, but I do talk about the numbers of women being low, and I think the hope is if someone hears that, then
Right.
they may feel more comfortable saying, okay, it's okay, I can do this too.
Okay, ma'am, first of all, I'm like really surprised and shocked about the numbers. Like, I mean, I knew
This is
that this,
electrical engineering, hardware engineering, but I think
yeah,
computer science and stuff have higher. I mean, I think the number of college graduates, undergrads is probably higher. It's actually much higher. But eventually, when IEEE did a survey in the number of engineering fields, where after a decade they see how many actually stay in the field. I'm
right.
quoting
I
those
think many
numbers to you.
leave. Correct, correct.
Yes, I'm quoting those numbers to you. Yeah.
Okay, like I did know that the number of like women are low, but I did not know it's so low. But I think now it's improving because like even I know many of, and I personally want to go into like the computer science field. I know many of my friends also who are planning to, like girl friends who are also planning to go into the STEM field. So yes, I think it's improving. And also, I remember once there was a guest on my podcast who asked me like, what is the reason? Like, why do girls in high school not want to choose, math heavy subjects like maths or physics? Like, what is the reason? And even I did not know, like I don't have a very specific answer, but
Um,
yeah,
yeah, I do think there is they are intimidated by the fact that there is an intimidation factor. And what exactly intimidates them, I'm not clear. But there is this thing that I'm not good enough. I do believe girls think that they have to be very good at something to be able to move forward. Boys, I do find this say, I have the aptitude. I haven't proven that I'm very good at something. I have the aptitude, so I'm going to do it. And that's a difference. Knowing that
yes,
I might have the aptitude versus I already am very good at it is two very different things. So girls
correct.
wait a little longer. They maybe need a little bit more feedback before they take that step.
Okay.
Again, I don't know why that is, but I think that's another thing when I speak to younger people, this is what I hear. Yeah.
Okay, I think yeah, that's one place where I'll agree with you. And also I feel like I think on that episode also I discussed this. I feel like girls yeah, they're a bit more intimidated and lack confidence in taking such
Yes.
steps. And I feel like
Yes.
even I personally have been in that situation where, like in my house, I've had so many discussions and arguments about if I should choose computer science, if I'm good enough, because there's so much competition in this field. Like everybody, like even in my high school, like many of my friends, they already know so many coding languages. And I feel like it's already a lost battle because like if people are already so ahead in the competition, then I don't know if
You're
I'll
too
be
young
able
to
to.
think that. You're too young to think that. Let me tell you, coding ultimately is logic, right? It's logic and it is understanding algorithms, it's understanding mathematics, it's understanding. I think if you have the fundamentals, you can build on it. It's never too late. I learned how to code in Python well into my 40s.
Oh
And
my God.
because Python came in, I mean, Python existed even actually earlier, but in terms of what I needed and when I needed to use it was much later.
Right.
You don't need to, you just need to have common sense logic and ultimately build whatever else is around it. I'm a hardware engineer, but I tend to use a lot of Python for other things.
Right, right.
And it's okay. As long as you say that I'm going to work and I'm going to learn, right? It's built on some fundamental basic, building blocks, and it's never too late. So what? You will learn a little slower. You will not develop as sophisticated code as your peer, but you will get there, right?
Correct. I think this is a very important message all the young STEM enthusiasts should hear. And I think, like literally I think 2 or 3 days ago, I was literally talking to my father about this, about how I feel it's a lost battle and I'm not sure I want to go for computer
Mhm.
science. And he told me the same thing that it's literally not late to learn. And you're still young, like you have so much time to learn and, advance your
And
skills.
you will be learning for the rest of your life, and suddenly when you are middle aged, you'll find there's something that comes along which you need to learn, and that's totally new. You're still learning.
Correct.
So
Correct.
don't this is where I feel, don't give up before you start.
Right. Right. Agreed.
Right?
Right.
So try it, and then you will decide for yourself. Yeah.
Correct. I absolutely agree with you. Ma'am, so moving on to the next question. Your passion for Western classical singing is fascinating. So, do you see any parallels between music and engineering? Uh, yeah.
So Western classical was a very late thing. It just happened by chance. But what I was trained in was Indian classical music, actually. But when I moved for my graduate studies, that access was limited. So
Mm,
it so happened that one of the professors in my department used to sing for the university chorus, and so he invited me along, and he actually was the person who taught me how to read Western classical notes. And and through that, I basically, I've always appreciated that structure of music is mathematical, actually. If you want to think of music in a very logical, structural way, it's purely math. In that sense, yes, there is a connection. But to appreciate music, I don't think you need to understand music. You don't need to understand the structure. You just have to feel it. And then in that sense, there's absolutely probably no connection. So it depends on how you approach it. And for me, I think the feeling is almost more important than the structure when it comes to music.
correct. Correct. I think I can
Yeah.
relate. Ma'am, can you elaborate on how like singing is related to math? Because I mean that's something which I've heard for the first time. So that's interesting.
Even when I was learning as a child Indian classical music, it was, you know the concept of ragas, right? In Indian classical music,
Yeah,
the
yeah.
way it is built, the octave and the structure of the octave and the notes within the octave, it's a very mathematical thing. You can break down within what we call a full note in Western classical, or between a sa and a re,
Mm.
in adjacent notes. You can break that down into halves and quarters, and you can, of course, you can slide along it, which is what an alap is. But the basic structure is mathematical, and you take that octaves and you repeat it over. That's what your harmonium is, your piano is, and ultimately that's what you
Wow.
vocalize, or your guitar is. Yeah. So yeah, the basics are when I say mathematical, it's a very, it's there is a structure to it.
Got it. There's like a
Yeah.
pattern kind of a thing which you can observe.
Yeah, 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 that's right.
I think
the
that's a
pattern
very,
the
yeah,
pattern is the raga. How you choose notes within that is the raga that you create. But the basic fundamental is, it's a very structured system.
got it. I
Yeah.
think that's a very interesting perspective. Something new I learned today. Yeah. Ma'am, if you had the opportunity to collaborate with any historical figure or modern innovator in the field of electrical engineering, who would it be and what would the project be you guys would work together on?
This is one of those questions I thought was very creative. I had no idea how to go about answering it. What I would say is the folks I work with now, the founders of my company, who also mentored me through the process in the early years, I wish I'd met them sooner, I think. Not just in terms of what we are doing, but how we go about doing something. I think they have taught me a lot, and I have learned a lot. Yes, we are trying to apply our problem to a particular solution right now, but in terms of how to think about thinking of a problem, how to solve this, how to like step back and think about it, I have learned so much from them. And I would say my answer is I wish I had met them sooner in my career. I think that would have really helped me. But yeah, I think I feel like I'm in a very good place right now in that sense.
Wow, I think it's really nice that you've already met I mean, my question was about imaginary people, like historical figures and all of that. But I think it's nice that you already met them. So you don't really have, an imaginary person who you haven't met till now or
You
you
could
have
also
wished.
term it as a limitation in my imagination. You could also say that. But it depends on how you look at it. Yeah.
Right. Now, okay, another creative question. If you could create a playlist of songs that represent different phases of your career and life, what would the top three tracks be and why?
Ironically, for the schooling years, it would be "We Don't Need No Education," Floyd. Just as a pun, I'm saying
Yeah.
that. There's something very catchy to it. And okay, the reason I say it is, I know it's a strange thing, but I think you don't have to follow the a path to get somewhere. I think that's what I take away from it, as opposed to I don't want to go to school and study. So I like that. What else would I do? I think the years you will have many years where you are going to burn the midnight oil. So I like "A Hard Day's Night," Beatles, that song. It's been a hard day's night. That would be a big chunk of your working life. um, and currently or throughout, what I've been is someone that likes to tinker. There's a song called "Scientist" by Coldplay that I like,
Oh,
which actually it says, I can't explain how I feel through science, so I guess it doesn't directly apply, but you know, I like that song, so I don't know.
I think you have a really good taste in music. It's pretty aligned to like our generation. Yeah.
Okay, thank you.
Welcome, ma'am. Ma'am, how do you see your work in semiconductors contributing to solving some of the world's most pressing societal challenges?
See, I do think climate change is a problem that has to be addressed.
Correct.
And I do believe that technology is one
Hmm.
piece of the puzzle, plays a role. Uh, Specifically in this case, how we make things more power efficient is part of a solution through semiconductors, but it's a very small piece of the puzzle. But broadly, I do believe that tackling renewable energy, how do we efficiently take it to the next level of efficiency, make it more widely available and economically accessible. And in these things, I do believe semiconductors have a role to play. So it's one part of the solution again, but it's an important part. So I would
Definitely.
say
Ma'am,
that
I
is the
like,
biggest.
yeah.
Yeah, yeah. Sorry, go ahead.
I like how you're mentioning, everything is a small part of the puzzle. Like, I think everybody around the world is solving just a small part of the puzzle. And I think gradually we'll reach that stage where the full puzzle is solved, hopefully. So,
Yeah,
yeah.
and I think there are thinkers who can take leaps. They should absolutely do that. If you are capable of doing it, take that leap. But for many of us, it may not be a leap, it may be small steps, and all of that adds up. And I
Yeah,
do believe
definitely.
that a lot of this work always comes as building blocks. You're building on somebody what somebody else built.
Correct.
Many of us. There are some who are fundamental thinkers and can come up with something brand new. So yes, so there are small pieces of puzzle being solved, and some people are just thinking completely laterally and building, taking bigger leaps.
Correct. But I think at the end of the day, everything contributes
Yes,
to
yes,
solving the
absolutely.
main puzzle, the main problem. Right.
Yeah,
Ma'am, so now it's time to switch gears and turn up the tempo because we are heading into the lightning rapid fire segment. This is where we
okay.
put our guests' processing power to the ultimate test with with a series of quick fire questions. So, ma'am, are you ready to blaze through the questions?
Let's do it.
Okay, so the first question, favorite tech gadget you can't live without?
I wish I could live without it, but it's the smartphone. I think without
I
that,
thought I
it's
knew
very
it. I
hard.
actually knew it.
Hmm.
Okay, ma'am, mountains or beaches?
Mountains.
Oh, okay. Favorite programming language?
Used to be MATLAB, but now Python.
Python, yeah. Last song you listened to?
Actually, it's a instrumental group called they're called Rodrigo and Gabriela. It's guitar flamenco music. So let's just leave it at flamenco music. Yeah.
Okay. If you weren't an engineer, what would you be?
I think something along the lines of embryologist. Something
Whoa.
where they are, or yeah, where they are tackling questions about life.
Okay. Uh, a Silicon Valley innovation or Korean technology?
It's a tough one. My bias says Silicon Valley innovation, but I think Korean technology is pretty cool too.
Okay. Favorite outdoor activity in Seoul?
Hiking.
Hiking, yeah. Adjective or phrase to describe your academic expedition?
Adventure, fun adventure.
Fun adventure. Yeah.
Mm.
So with this, the eighth episode of STEMness Voices comes to an end. I would like to express my gratitude to Ms. Soumya Krishnamurthy for taking her time to provide us with so many valuable insights. Thank you so much, ma'am, for joining us today.
Thank you, Trisha, for having me. It's been a pleasure talking to you.
Thank you so much, ma'am. Last but not the least, I would like to thank all our listeners for tuning in. If you like this episode, don't forget to like, share, and subscribe to my podcast. Thank you.